Welcome to Next in Tech, an S&P Global Market Intelligence podcast where the world of emerging tech lives. I'm your host, Eric Hanselman, Chief Analyst for Technology, Media, and Telecom at S&P Global Market Intelligence. And today we're going to be talking about 5G, but also looking at some of the Internet of Things aspects of it. And joining me to talk about that is Principal Analyst Rich Karpinski. Rich, welcome to the podcast.
Yeah, thanks a lot, Eric. I look forward to it. Appreciate the opportunity.
Well, and great to have you on. We were both out at the 5G Americas conference, and there were so many interesting things that were going on around that. This is an industry conference that brings together a whole set of the different participants in the 5G market, operators, equipment producers, chuck in an analyst or two. But it's an interesting forum where there's a lot of discussion about all sorts of different pieces of 5G.
Yeah, it's an excellent conference. I've been going to it for quite a while, and I think the conference itself reflects a little bit the evolution of 5G. Certainly, if you look at it over a long period of time, you can see massive change. When you look at it sort of year over year, shorter periods, it can feel a little deja vu-ish, like we talked about this last year. And so I think that sort of speaks to the challenge of 5G itself, which is it's a long-term technology adoption and development and deployment scenario, but everybody wants to rush and see the changes right away. So I think that'll be a good part of our conversation today as well.
Well, and it's been going on long enough that it started out as the 3G Americas conference. So
exactly,
they've been doing this for a while. But the other thing also that I thought was interesting is there's a Wall Street Journal article that came out when podcast goes out the week before we're actually going to go live, that was talking about 5G and how it hasn't lived up to its promise. And it's interesting to contrast that kind of things that we were talking about at the 5G Americas conference and where this all came from. I mean, this is something where if you think about like any transition in technology, there's a lot of hype that accompanies it. And yet underneath, there is some intrinsic value. But I think what the journal article was talking about is a lot of the things that people felt were going to be mega hypey haven't really panned out.
Yeah, it was a fairly critical article, but I think it was in many ways fair. And I think most of the folks, the operators and the vendors at 5G Americas or other places in the industry would probably admit it as well. So just as a baseline, they shared some numbers I think might be worth putting some of this into context. So some of the numbers that were quoted at that event were 1.5 billion connections by the end of this year, which seems like a massive number, but it's, again, just a portion of overall mobile connections. The idea would be 50% of mobile connections would be 5G by 2028. And what we're talking about there mostly are smartphone connections. And at least part of the promise of 5G is the idea that you would be moving beyond just your smartphone into having many things connected. In the consumer space, it'd be your wearable, it'd be your home, and in the enterprise, it would be everything from a factory to your supply chain, vehicles, goods within a supply chain. So I think we're much less advanced in that area for some reasons that we'll talk about. The other thing is just the geo difference or deltas. So some of the data that was shared there was when we talk about that, those 1.5 billion 5G connections today, about 41% in the US, 33% in China. Then you get down to 13% in Europe and less than 1% in sort of the Mideast, LATAM, and Africa. So that's a big difference. And it's not so much a have and have not, because this fallback is a pretty good 4G LTE network in most cases, but it does show some discrepancies between geos and pace of adoption and reasons for adoption that I think were really at the center of that Wall Street Journal article. And, the other thing I'd point to is I've been in the telecom industry, the mobile industry for quite a while, and this is pretty common. And what sort of gets hidden, if you think about sort of the big exploding technology today, which is sort of ChatGPT and generative AI, seem to have come out of nowhere. And when consumers got their hands on it, all of a sudden there was massive adoption and massive disruption. Underlying that were decades of development, which is very similar to the decades of development of mobile technologies, 3G, 4G, 5G. But with the web and with those kinds of technologies, the day that consumer can get access to it, there are almost no limits. The adoption curve is much different than just the plain deployment curve in 5G, right? Once it's available, there are price issues, there's availability issues, there are device issues. And then the network itself has to be deployed out to many, many locations. So it's just a different sort of feel in terms of technology adoption that often is viewed as being lagging.
Well, the ecosystem is complicated, as you're pointing out. I mean, there's so many different chicken and egg pieces in this.
Yeah.
So many places where the market has to develop for people to invest. And for people to invest, the market has to develop.
Yep.
And all of this sort of back and forth in terms of moving this forward. And again, you look at some of these adoption numbers. That was one of the things that I was surprised about, just in terms of what that transition was looking like, and the fact that there are just massive discrepancies in terms of adoption.
Yeah, I think US and China, very interesting. It's viewed as a competitive issue, right? And seeing China get out ahead of that is, well, although it's 33%, it's a big number off of a big population base, right? And there's also a lot of government support for that. Here in the US, it's more private industry driven, and there's just those economic factors that we talked about. You're mainly talking about a smartphone connection. Interestingly, probably the first non-smartphone market to open up is sort of fixed 5G, fixed wireless, which is a replacement for cable or internet access. And it's a decent sized market. It's a couple of million today. I think some of the individual carriers expect it to remain single digit millions, but that happened pretty fast. It was sort of a marketing thing. I think T-Mobile especially was able to market it very successfully. And the availability was sort of instantaneous. It was driven by the operators. It was TV replacement or internet access replacement, and it was kind of straightforward. A lot of the other adoption scenarios are much more complex.
Well, and it is in a world in which there are a lot of competing alternatives because it is displacement for other broadband technologies.
Yeah.
Whether or not those are traditional broadband, now we've got satellite players. Actually, I want to bring up some satellite stuff later.
Yep.
Lots of different pieces to this. So a lot of complex dynamics.
Yeah. And for smartphone users, even if you have a 5G phone, if you're traveling, you're perhaps frequently falling back to a 4G network, and you're not probably seeing that much difference. Right? You may get higher throughput, but is it going to affect your calling? Is it going to affect your collaborative apps? Is it going to even affect your Netflix streaming? Probably not. Right? So from an everyday performance point of view in that realm, smartphones, it's an incremental improvement. But as we'll talk about, it's a fundamental improvement of the network and takes the network itself to places where it needs to be if operators are going to move into new businesses and new applications are eventually going to be supported. It's absolutely a requirement.
Yeah, it was interesting seeing some performance metrics, in particular when I'm thinking over out of Telstra in Australia that I saw back at the beginning of this year. It was talking about 4GE LTE Advanced Pro, later generations and adaptations of 4G environments that were actually in many places outperforming 5G just simply because back-end network connections were faster as part of this test environment.
Yeah. And at the same time, I think you showed me your phone at one point at this conference and you were on 5G and getting really good throughput, right? And it's like a momentary wow. And then you just go back to your life and it's not that wowful, right? It's you're sort of living the same smartphone life, right?
Well, and it gets to that question of just because you can get however many bazillion megabits.
Yeah.
Do you use them and does it actually have an impact on your experience of what that network is?
Yeah.
Now, the other part of this is that while the cell phone piece is a big piece of this, the Internet of Things aspect is another part. And that was originally some of the promise that 5G was going to have the potential to be this next new venue to do the interconnection of all the machines and all the things that are out there.
Yep.
But some challenges there too.
Yeah. In its ultimate incarnation, will serve the Internet of Things, enterprise applications, sort of massively scalable, ultra low latency applications extraordinarily well and better than today's technologies. But what you have today is good enough. And I think that's one of the sort of catchphrases of the web and the internet, how it's developed. It's not perfect, but it's good enough to get a job done, right? And so that's what you find with today's IoT connectivities technologies, which are sort of under the banner of LPWAN, so low power wide area networks. And you've got things like NB-IoT and LTE-M, LTE based technologies. You've got things like LoRaWAN, which is sort of a non-cellular technology. And all of these do a pretty good job and have had a runway to develop and have devices be available to have wide network connectivity available on a global scale, to have an ecosystem of the carriers and network operators, and then virtual operators who can bring together multiple carriers for the convenience of the enterprise. All of this works very well. It's low power, which you need for IoT. It's relatively low bandwidth, which most IoT connections, that's all they require. And so that's doing the job for the most part and gets the job done. Now, 5G, again, in theory, does it much better, but 5G devices, machine devices, sensors, there's not a lot of availability today. There's a time frame from when the network becomes available to when chipsets become available to when products become available. We're very early there. And the industry itself is trying to do some work to get around those limits. And I think that's probably where the most interesting 5G developments are happening in terms of IoT these days.
In that we're in the midst of a transition, but that it's still more expensive to give your thing a 5G connection than it is to give it a 4G connection.
Yep.
And to your point, it was the shift to 5G and the repurposing of a lot of spectrum actually shook out the fact that there were not an insignificant number of devices out there that were running on 2G connections before that spectrum got repurposed and had to be transitioned over into this new realm, which just, I think, is an indication of technology transitions are complicated and they take long periods of time. And we're in the midst of this. But in the IoT world, we're looking at a set of things that can potentially make that simpler in the 5G realm.
Before we get to that, I mean, these are big decisions in the enterprise realm, right? So if you're talking about IoT, you may be talking about thousands or tens of thousands of endpoints, right? So it's not non-trivial to swap that out or swap a device out or swap a card or a SIM card out. It's a big thing, right? And enterprises, industrial enterprises in particular, sort of more asset-heavy industries, they think in terms of decades anyway. They're not swapping things out like a teenager at T-Mobile every year for a new iPhone, right? They're thinking in terms of decades and more. So that's a big part of the challenge as well. But I think what you were getting at is the industry is well aware of these challenges around IoT. They see it as a massive, probably yet unfulfilled opportunity, especially the cellular providers. And so what you have is 5G targeting consumers and smartphones and home internet access today. What's coming down the pike, and the 5G standards come in releases. So the latest releases are beginning to be commercially available, have been finalized and now becoming commercially available. And this thing called 5G RedCap. So it's a nice acronym, right? It kind of sounds fancy, but it basically means reduced capabilities. And what you get with that is a simpler version of 5G, a little less bandwidth, probably around 100 megabits, maybe up to 150 megabits, less complex, fewer power requirements, so to compete with LPWAN. But it's, that 100 megabits or so is orders of magnitude bigger and more throughput than the traditional LPWAN connections. And so you've got a nice sort of mid-tier capability here that's beginning to roll out, right? And this is the problem, it's just beginning. So we're just getting into operator networks. There's been some trials, very few devices, but a lot of interest and activity around it, and a lot of hope that this could be the thing that really makes 5G-based IoT take off.
But again, back into that situation of we have to have the capability. It's got to be rolled out with enough coverage in networks to make it attractive for manufacturers, to get the volumes up, to get the costs down. Same cycle again.
Yeah, so I think the industry thinks or hopes they have it defined correctly, that it will be appealing. And then it's that horse and cart, chicken and egg kind of thing. The one thing that might be going towards its advantage is these long cycles we talked about. And does anybody today in an enterprise want to invest in last generation technology? So do you want to put a 10-year investment into 4G based technologies, or do you maybe want to think about being a little ahead of the curve, get in early on 5G RedCap, and then have a long runway in which you don't have to think about another transition again? So, if you can hit that sort of transition spot right, with the right offer, this might be something that can really help 5G IoT take off.
Until we get to 6G.
Yeah, exactly. I don't know if you've talked about 6G on this podcast.
I have not, but yeah.
We've had some inquiries, which I've mostly punted, and I think it's probably a good thing. And what we're seeing here with 5G and with the standards around 5G is this move away from this 10-year cycle of 2 to 3 to 4 to 5G, right? And to have some dot releases and some incremental releases in between that are more market driven, that meet requirements, and that don't point to some far off, wonderful technology that sort of never comes. And as it comes, everybody complains that it's lagging. And so these sort of smaller releases in between, I think fit probably more towards what's required and the mindset of enterprises and technology adopters today.
Well, and you think about some of that long time frame.
Yeah.
What are you going to invest in? And one of the things that were kicking around was automotive environments.
Yeah.
In a place where there's a long design cycle, there's certainly a very long life cycle once it's actually in the car.
Yeah.
And a lot of huge promise, but again, a lot of balance there in terms of what the manufacturers are willing to commit to.
Yeah. I mean, this is a massive opportunity, but what you just described is also a pretty significant challenge. So you have both on-car considerations for tech and you have sort of off-car considerations. So on-car, if you've got a vehicle today that's relatively advanced, so say a Tesla, for instance, you're going to have a network connectivity within that car. It's going to be LTE. It might be LTE for the foreseeable future. And every time a car gets on the road with LTE, it sort of pushes the LTE window forward, right? Because those cars are going to have a long life. They're not going to be swapped out like a smartphone again. So that's a challenge. We're really looking at EVs and more connected cars and connected car services and even the beginning of ADAS and autonomous driving. And 5G is not ready, set to go yet. So it's sort of a mismatch of timeline, which is really unfortunate and will complicate things. But at the same time, you're going to get a more connected car, which is important, right? And offers a lot of room for growth and innovation. The other thing is the car is going to start talking to the network and to the infrastructure around it to some extent. And I think this is really the largest hope for the telco and operator industry is to build out that infrastructure that sits beyond the car and the car talks to and provides really meaningful insights. So you might be able to, while you're driving down the road, your car may be able to sense what's going on around it with all the cameras and sensors and connectivity. But if something's coming out of line of sight, or if there's something to look ahead, the car could potentially, via cellular network, a 5G network eventually, talk to the infrastructure. The infrastructure could talk back to it in the terms of milliseconds, and you would get some really vital information around safety, right? This is the big opportunity around the auto and mobility industry for the telcos. It's also very, very speculative at this point if that massive infrastructure opportunity will come into play.
And this is the promise of edge computing, right? Or at least one of the edge computing use cases.
Yeah.
Is the idea that, hey, we've got to be able to work with all of the requirements to do getting data to vehicles in sufficiently real time. And whether or not that happens to be simple things like traffic updates or complex things like environmental capabilities, the smart cities integration of where am I going to park when I get there, those sorts of things. The promise, to your point, is that there's an awful lot of compute capacity that would be useful to be able to manage it. But again, you get into this ecosystem issue of who is going to actually consume it, who's going to pay for it, and do they have to build sufficient capacity before it becomes useful? Does there have to be a lot of capacity on network?
Yeah.
More complex transitions in that area as well.
Yeah, I mean, I think it's fair to say at this point, the edge is going to happen, right? Edge compute, nearby compute is going to happen. What form that takes, what applications or use cases drive it, who owns it, and how that shakes out is very much up in the air and is really impactful for the future of 5G networks and the operator business model. I mean, operators would love to own a good part of that infrastructure. And part of the way 5G is set up is to begin to put intelligence into the network that can take advantage of and be integrated with local edge compute. And in an ideal world, and we're beginning to see some deployments of public 5G networks with coupled edge compute, which in the telco world is called MEC or multi-access compute, another great acronym. We're starting to see Verizon and others start to lay out public MEC, and there's private MEC as well, which would replace or augment private networks. But again, what are the applications that are going to be driving that? They're probably not here today. The V2X, so the vehicle to the infrastructure, is probably one of them. A lot of metaverse, XR, so augmented reality, especially, might only be possible at scale leveraging something like that, a network connected edge and high speed wireless, but it's not here yet, right? And so most applications and use cases can be supported using other technologies. Would it be more elegant to do it via 5G and connected edge compute? Yes. Will that might be the ultimate architecture? It might. But when there's those gaps in windows, other vendors, other technologies, which we saw in the cloud age, right? I mean, telcos wanted to be cloud providers and it just didn't work out. And others, when there are large opportunities, flow in to take up that opportunity if someone like an operator is too slow to get it. So it's all very speculative. It's very interesting and it has a lot of upside, but it's, as I said, extremely speculative at this point.
Yeah, and lots of other things that are chasing around at the conference. I thought it was interesting, a little bit of what's happening with private wireless. But again, that's another of these things. The idea that you could have either your own network or your own chunk of the network on your own. But again, a lot of the work in those environments, the promise is if you've got a big factory environment and you ought to be able to go run your own telco wireless network as opposed to Wi-Fi because it's more secure, more potentially reliable. But yet, the examples that mostly exist out there today are mostly 4G.
Yeah.
Again, because of some of the costs of deployment.
Yeah. I mean, this is the decades, if not centuries long challenge for the telcos or operators, right? They don't want to deliver a dumb pipe. They want to deliver an intelligent network. And so dumb pipe are very valuable. They're just easy to deploy. They're cheap. And then you move all the intelligence someplace else that you control. It's not in a third-party network. And we're seeing that sort of same challenge now with 5G and edge compute. And we talked about sort of the pathway forward for 5G and the idea of releases, right? So when we start getting to the next couple of releases of 5G, you get into something called 5G standalone, which means the entire network, both the radio network and the core network, is completely 5G native. Today, most 5G networks will have a 5G radio network that will then take advantage of core that was built for the LTE network. So it's sort of split, right? But when you get that 5G standalone network, and then beyond that is 5G advanced, which is the next major rev of the standards, you begin to support the kinds of things we've always talked about with 5G, which is ultra low latency, less than 10 milliseconds of round trip time, which lets you do really interesting things. It's very wide and ubiquitous coverage, right? And you even get into things like lower power and things that make sense for sustainability and other kinds of requirements. So when you get to that point, things become, again, very interesting. Telcos start to run intelligent networks that have open APIs, that deliver things called network slices. So a piece of the network that's pre-built to very much support a particular application. T-Mobile has already released something here around video and collaboration with a network slice. So all of these things are kind of the ultimate endpoint for operator networks and wireless networks. Again, a little ways out. What happens when we get there and what happens in the meantime before we get there?
Well, and one of the things that is everybody keeps talking about again, more promise and hope, the idea behind Open RAN, the Open Radio Network, the idea that we've got the ability to be able to now have open standards in the radio world so that we're not dependent on a relatively small number of manufacturers for this.
Yeah.
And that's moving forward, but that's sort of one of those things that we think about the environment. It was interesting seeing some of the push and pull about Open RAN that was actually taking place because, of course, the incumbent manufacturers are not really keen on completely opening up the world to a whole set of competitors. And yet there are a set of interesting competitors that are doing some interesting stuff. And this comes, of course, on the heel of virtualizing the RAN, basically taking what was an entirely physical environment, now starting to do all the virtual machine and containerized kinds of transitions that we've done in other parts of computing, but early days for that as well.
Yeah, I mean, I go a ways back in telecom. So Bell days, Bell System days, RBox, regional holding companies, divestiture. And that was not a very innovative environment. You had the wonderful place of Bell Labs, invented the semiconductor, the laser, et cetera, but as a way to move innovation forward into a commercial environment, very closed environment's not the way to go, as we've seen with the web and the internet and the cloud, et cetera. And so the adoption of more open architecture, the ability to use off-the-shelf compute capacity, the ability to take the next virtual function, whether it's RAN or a core function, and move it into a more distributed environment, maybe host it with a data center provider rather than within the telco four walls. All of these things are being leveraged today, are extraordinarily interesting, but are very complicated for all the reasons you described. I think there's a lot of promise in all of this idea of open RAN, open APIs, network as a service, et cetera. I would say that they're going to be extremely critical, but they're going to be critical for applications and use cases that we probably aren't thinking about today, again, which is both the opportunity and the challenge facing the mobile carriers.
Yeah, that's the thing. We need to be forward thinking enough in terms of what those use cases are. The other thing that was interesting was hearing about non-terrestrial uses. So it's like 5G in space,
yes,
kinds of things, but it's satellite.
Yeah.
And we've got iPhones today that are able to do very simple messaging as satellite.
Yeah.
And again, later releases of 5G that start to make that more of a real thing.
Yeah. I mean, if you think about IoT and the promise of IoT, it's that you could find a connection for anything, anywhere. And we're clearly not there today. We started off talking about how much of this is smartphone driven. An interesting term being talked about, there were a couple of sessions where this came up, was this idea of ambient IoT, which is, really the idea of connectivity, probably fairly low bandwidth in most satellite connections, whether they're traditional satellite or the new idea of low Earth orbit satellites are going to be relatively low connection, but they can be everywhere, right? And the idea of the ambient IoT would be that you can find a connection anywhere and all of it's going to be relatively low power or extremely low power or even no power. And there are some sort of constructs to sort of generate power almost out of nowhere at that very low requirements. And so a massive promise of IoT, it's somewhat science fiction-y, right? But that's a lot of times where we end up is not where we expect, or what we've dreamed about becomes real. And a lot of this is in that realm where you can picture a future where there's constant connectivity and there's devices everywhere and everything has a device on it. Every product you have or everything that's put out by a manufacturer has some sort of sensor on it that can talk to something somewhere. And we're definitely going down that path. And so all of the things we're talking about today are what enable that, right? New technologies or new forms of technology that enable that real vision.
Well, and we see certain use cases today that are actually starting to leverage some of that promise. I keep thinking it's kind of like that William Gibson quote, the future is here today, it's just not very evenly distributed.
Yeah, exactly. We've talked to some folks who do, and there's actually multiple vendors who do fire sensors and then place them in large forests, right? And they leverage satellite connectivity to give a heads up for when a fire starts, right? Things like that are being applied today. So it's a challenge to support that use case economically, right? And so that's the challenge for those vendors, but you can see the value in it, right? And you can't do that with existing technologies. So there you see a problem, you see a solution, see the economics start to play out in the right direction, and then you get some movement.
Well, we'll have to see where this all goes, but it was certainly interesting to get a start in terms of some of where this was.
Yeah.
There's certainly a lot of potential. We'll have to see the directions which it plays out.
Yeah, it was good to see you last week, and thanks for all the time today. I appreciate it.
Well, thank you, Rich. And that is it for this episode of Next in Tech. I want to thank our audience for staying with us. And thanks to our production team, including Carolyn Wright and Caitlin Buckley on the marketing and events teams, and our agency partner, the 199. I hope you'll join us for our next episode where we're going to be talking about data migration. It's fall, the migratory season, but we got to think about where data is moving. On-prem, off-prem, into cloud, and back. Henry Baltazar is going to be on to talk about some research work he's been doing recently. I hope you'll join us then, because there is always something next in tech.